On practice problem 34, it gives us a baseball diamond with sides of 80, and then the distance from home to the pitcher's mound of 54.5 feet, and it wants us to solve for various distances. So the first thing that it asks us to solve for is the distance from the pitcher's mound to first, so that would look like this triangle. And we are solving for this length. Okay, so this angle right here is a 90-degree angle. So when the distance from home to the pitcher's mound intersects it, it's going to split it in half. So this, we know that this angle is a 45-degree angle. And that gives us a little start, because then we know two sides and the angle opposite the side that we're looking for, so we can apply law of cosines. So let's go ahead. We have L squared equals 80 squared plus 54.5 squared minus 2 times 80 times 54.5 times cosine of the angle opposite of what we're looking for. So that would be 45 degrees. So basically you type all this in your calculator, and then remember to square root it to get rid of the square. And we come out that L equals 56.6064. Always remember to round what it wants. I see that it wants 2 decimal places, so let's go with 61 feet. Okay, so now the second thing that it went on to ask is the distance from the pitching rubber or mound to second base. So that's basically, let me draw another triangle. It's this back half. It wants, basically, here's second, here's the mound, here's first. And let me show you, let me draw it with home included so I can show you something. Okay, so here's home. So we know that this side length is 80, this side length is 80, and this side length right here is 54.5. That's hard to see. Okay, so, and we're looking for this length. Well, this is actually a 45-45-90 triangle, because this line right here intersects what was a right angle and makes a 45-degree angle. This one is the same thing, makes a 45-degree angle, and then this end of the diamond is a 90-degree angle. So what we can do is we can apply Pythagorean theorem. So basically we know that L plus 54.5 squared, that was our hypotenuse, equals 80 squared plus 80 squared. So let's go ahead and do that. So L plus 54.5 squared equals 12800. Now to get rid of that square, we're going to square root both sides. So we have L plus 54.5 equals the square root of 128. Now to get L completely by itself, we just subtract, 800. So if you type that in your calculator, you will get the length of L, which is what we're looking for. And I get that it is 58.6371. It wanted 2 decimal places, so 58.64 feet. And that's how to solve for the distance from the pitching rubber to second base. Now it asks, it basically states he needs to turn around at what angle to his left. So if the pitcher is facing home plate, through what angle does he need to turn to face the first base? So let's get another piece of paper. And let me restate that. So if a pitcher faces home plate, Through what angle does he need to turn to face first base? Pitcher faces home, but he needs to turn to face first. So remember back up here, we're looking for this angle. So let's work alongside that. Just applying, and remember we saw that this was 56.61. So since we know all of those different lengths, and we're looking for this, let's call it theta, we are going to need to apply the law of cosines. Well, we could apply law of sines. I'm going to go ahead and apply law of cosines, just because I know that it will work. So 80 squared equals the 54.5 squared plus 56.61 squared minus 2 times 54.5 times 56.61 times cos of theta, which is what we're looking for. So, of course, I'm going to write this really funky because I know that this is what it will look like in the end. This right here minus this divided by this. And that equals, let me type it in the calculator. That equals 92.0942 degrees. And round that to 1 decimal place. And there we go. That is how you solve problem number 34, which deals with the baseball diamond.